This lesson that we're going to take a look at starts to deal with triangles which are not right angle triangles. So far throughout all of our trig that you've done in grade 9, grade 10, and a little bit now in grade 11, it's always been dealing with a right angle triangle. It's always been dealing with um, finding sides and angles and such if we have a right angle triangle. Today we're going to move away from that, or sorry, away, go the opposite way, and we're going to move into triangles which do not have a right angle, and how can we find the side length or an angle of those triangles. The first thing that we're going to be taking a look at is something called the sine law. Now, sine, you should remember, is from sine of theta is equal to opposite over hypotenuse. It's that same function, but now we're going to deal with it in non-right angle triangles, and it's going to be in a bit of a different sense, but we're still going to use sine, and we're going to still use that function on your calculators. So here is the first little activity that I would normally have done with you as a class, but we're going to do it a little bit different here today. I'm just going to go through it really quickly. I have 3 triangles on the first page. Now, I've done the measurements already and gone through and written those out, and so you don't have to do those anymore. But you can kind of, if you had the paper in front of you, I would have gotten you to measure out each of the sides and angles of each triangle. Now, normally I would have had you do one triangle, and then there'd be 2 other groups who would have done the other triangles, but that would be kind of the way that it would have gone. So, but because we're not able to do that, I've done them for you. What I did is I labeled I went through all the sides. Okay, so this first triangle here, we have A and B. So this one right here is little a, this one's little b, this one right here is, or this angle is big B, and this side is little c. Okay, so if we label it out, this is what it would look like. And I put in my measurements here. So little a was 8.1 centimeters, and then we have angle A is 50 degrees, and so on and so forth. Now, what we would do in class is we would try to see what happens if we take the side length divided by the sine of our angle. Okay? And so 8.1 divided by sine of 50 is 10. I'm not typing it somewhere there. Let's get something that is not being used. Okay, 10.57. That would be our answer there. So that's our side divided by sine of our angle. If we do the same thing with B, 9.4 divided by sine of 63, the answer is 10.55. And in the final one there, we have 9.7 divided by sine of 67, and that is 10.54. Okay. So if we do this for each one of these here, you'll notice how all 3 of our answers are very similar. Okay, in fact, they are quite similar. Now, if we could actually, and that is from my rudimentary measurements, just using a ruler on a piece of paper, okay, and a protractor. It's not even necessarily exact, but they are very, very, very close. Okay, all 3 of these. Now, I'm going to do the same thing for triangle 2, okay, and 8.5 divided by sine of 47, 11.62. And this one right here, 6.1 divided by sine of 31 is 11.84. And this one, 11.5 divided by sine of 102, 7.75. Okay, these ones a little bit farther apart, okay? Not quite as close, but still ballpark, still somewhat close, okay? They're somewhat close. The last one here, and that could have very well been because of my bad measurements too. The last one here, let's see, 10.5 divided by sine of 90, which is 1, so this is 10.5. This is 6.7 divided by sine of 40, and this is 10.42. And 8.1 divided by sine of 50, and this is 10.57. Again, you'll notice fairly close. So what that could tell us is that if we do this for each kind of grouping of sides and angles, we should in fact get the same number across the board. So our comparison tells us that a side length and angle are somewhat connected. Okay, so B and little b, big C and little c, big A, little a, they must be somewhat connected. And in fact, they must be very similar to the same thing across the board for a triangle. Okay? And that's what we're going to kind of use as a recommendation or as a guide for sine law. And we're actually going to look at a proof as to why this works every single time.